version of RCNN came in 2014. Whatever I discussed the theory for RCNN, it's depicted in the form of a pictorial representation for your easy understanding. We start with your input image, right? This is the input image, and which applies different algorithms, image processing algorithm. It go through a region proposals. I told you like it's like thousands of regions, tiny regions is going to propose. It was a very time consuming process. That is why we go for more practical version of RCNN, which is the overfit algorithm. So the original theoretical paper, so each and every region is rescaled for pre-trained model. Enter into the pre-trained model, we go for the prediction. Because here you could have think over it, why we have not used bounding box regressor. If anybody asks you, what could be the answer, you can tell. Because we only navigate the box across the image. So each and every locations we keep the box, we keep track of LOCs, isn't it? We keep track of the LOCs. We know the coordinates. What is the top left coordinate? Because I only move my sliding window. Whereas this is in the original paper, it is automatically it is returning some shape. The algorithm does not have any idea that whether this is a useful, it is a very useful or it is a useless. Unless otherwise it's fed inside the pre-trained model, then only it will come to know that. So model has to learn the bounding box coordinate. It has to go through the learning process. So you just think about the complexity. So parallelly, the model has to learn the coordinates also. It has to learn the class label. So that is why the more practical version of the original paper is implemented in the form of overfit algorithm, which follows the sliding window technique plus image pyramid. Get the ROIs at multi-scales, and we pass on to the pre-trained model. ROI with the maximum probability is retained along with BX, BY, BH, BW. This is we have been collected in LOCs, locations, and the images are collected in ROIs. So more simplest version of your original RCNN implementation. Later on, two quick improvement that happens in the subsequent year. You can notice 15 and 16. What people have realized it, if we do the region proposal on the raw image, this is my original image, import image, in which we have the grayscales, right? Better apply CNN layers, and then get the feature map. You know that CNN layer is going to return the feature map. So what is the beauty of the feature map? Majority of the portions, the background portions, you know that your CNN layer is going to give the zero response. Most of the places where the constant backgrounds are there. But when you try to apply the region proposal on the original image, each and every tiny variation, even in the background also, the algorithm is going to propose. So I wanted to speed up this process. I don't want to waste too much of time spending very tiny regions. Even a slight contrast happens, changes in the background, that region also is going to propose. So better you first apply CNN layer, get the feature map. In the feature map, you apply the same region proposal algorithm. But only difference here is, instead of proposing nearly 2000 regions, when you apply the region proposal in the, of course, the max pool output, lot of redundant pixels are dropped, and most of the backgrounds are zero. You have very few non-zero elements are there in the form of the features. So obviously the algorithm is going to work a bit faster and is going to propose relatively less region, few hundred regions instead of thousands of regions, because many regions are zeros backgrounds. But ultimately the same idea. So the only difference is, instead of doing the region proposal on the raw image, it is going to do the region proposal in the feature map. That is a major difference past RCNN. Are you getting it? Within a year, there is a little refinement people have done for the fast RCNN idea in the form of faster RCNN. That idea looks bit faster. The reason is, okay, the idea looks very cool. Instead of proposing a region in the original image, proposing the region in the maxpol output, that is a feature map. It is very interesting idea. But why still you are trying out the default algorithm, region proposal algorithm? Why don't you try overfit idea here? What is overfit idea? Use your own your ROI. Okay. See, this anchor box concept, the terminology is being introduced by the YOLO team. Okay, it's a new jargon, just as a jargon. It's nothing but your sliding window. Okay, so far we are using this whatever the bounding box, we use the term called bounding box or the sliding window. And please ignore this term. The same meaning is what the sliding window. Okay, so when I talk about the YOLO in the next session, we talk about this anchor box. Anchor box is the new name they are the researchers, the YOLO team researchers are giving to the sliding window. So what is the idea of the sliding window image pyramid technique? That is the overfit algorithm. We use a fixed ROI, and we move across the image and we pass each region to the pre-trained model. We get the class label, isn't it? So when compared to the fast RCNN uses region proposal technique in the feature map, whereas the faster RCNN, instead of selective search region proposal technique, they use a simple trick over here. What trick they were doing is, here what happened, no, it is proposing, see, even though majority of the backgrounds are 0, still there are so many boxes will be there, few hundreds of the boxes will be there. They wanted to actually, the theoretically speaking, whatever they have proposed in the original paper, I'm telling you, but practical version of this faster RCNN is you can use the same overfit idea over here. That is the practical version of this. But in the original paper, what the author has discussed over here is to shortlist this. Okay, it's a time-consuming process. You don't need to pass each and every block to the mode, so it's a waste of time. What they are using, one small binary classifier they are using it. The name of that binary classifier model is called as region proposal network, RPN network. What is the role of that network is, it is going to simplify the process, simply going to say that discriminate whether it is the foreground or background. We are going to train the model. Already background regions majority is given as 0, but still here the differentiating the foreground and background is onto the context of the classes you are talking about it. Say for an application, suppose you are building an application for road traffic monitoring. Okay, for the road traffic monitoring. Why again and again I'm using this example? Because for the YOLO, I'm going to demonstrate this for this case, and for the live video feed also, I'm going to use this road traffic monitoring images as an example, so that you can easily connect with. Suppose here my application is to differentiate, to detect the object like a car and a pedestrian and a motorist. Okay, assume only these three. So most of the constant regions, backgrounds, or even in the feature map, it has become almost 0, 0, 0. But still, there are few residuals in terms of within the constant region itself, few edges related to some buildings, background buildings, few edge portions related to some tree regions, very far away background, few things. Still few traces of the background will be there. It won't be completely, it won't eliminate with zeros. Still few traces will be there. So ultimately what happened, your region proposal is going to get suggest this region also, because it's going to apply the traditional image processing algorithm to propose each and every tiny, and they are going to use one small sub model, small sub deep learning model to differentiate if it is object related features. My model should say it is a object related feature. This is the background. How the model will understand? We have to train it, because only for the object regions only you have marked the label, right? When we do the labeling, we don't mark the label for other regions other than the bicycle, other than the car, other than the pedestrians. We don't mark the label. So model will easily recognize that, okay, this is not being marked by the user, so it is should be considered as a background. Whichever the region is being identified by the labeled by the user should be learned as an object. So this region proposal network is going to learn to identify which is background, which is object related pixels. But this guy cannot tell that whether it is the car is inside, whether the features are related to the car or the features are related to the bicycle or the features are related to the man. This guy will not know. The main role of this submodel just to discriminate whether it's the background, or in simpler, maybe if I use the term background, maybe little misleading you. Maybe I can say that other than the object. Okay, the features other than the object. Even suppose in my frame, there is a big truck, but the big truck is not part of my label. Please understand. My label is only three: what car, pedestrian, and two wheelers. The big truck is not part of my object. So this binary model, this region proposal network, is going to understand only whichever the objects I have marked consider as the foreground. Rest all others, including the other object which is not part of my label, also it is going to consider as the background, including the building, including the trees. So this is being trained like a binary class model. So finally, obviously, I'm not going to worry about the background, only the foreground, and I'll ask the pre-trained model to return the class probability. Okay, this is a potential foreground. You tell me whether this is a two-wheeler or it is a car or a pedestrian. So that model is going to give the class probability. So there are two submodels, one binary class model to discriminate foreground or background, and one model to give me the class probability. So thereby they speed up the process nearly 10 times. They speed up the process. Also, they show the overall mean average precision score. They increase by 3% in this paper. So the original papers are available. Maybe along with your next session, in case if you find it difficult to download those original papers, it will be given to you along with the attachments.